Professor Chris Stringer, thanks so much for coming on to Evolution Soup from your office in Kent here in the UK. You are a researcher in human evolution, Department of Earth Sciences in the Natural History Museum in London. Specializing in human origins, you are also the author of several books, including Our Human Story, now out in a brand new edition, and have featured in countless documentaries and specials talking about new finds in human origins. Well, welcome to the show, Chris. You always seem to be traveling or recording interviews for television. So what has the past several days been like for you? Busy or a relatively quiet week at the office?
But yes, I'll be in the museum on Wednesday, and at the moment I'm working on some publications. So working on a big review paper about dating fossil human remains, trying to get a couple of projects moving on at the museum, including one on proteomics, which we may talk about a bit later. And I'm also, generally helping the collections staff at the museum get some of the collections in better order. A bit of recuration work, helping my colleagues.
Well, today we'll be talking about the new human species Homo longi, also known as Dragon Man, revealed to the public in 2021. But before we step into his world of 146,000 years ago, let's just hear a little bit about where it all began for you. You've been at London's Natural History Museum since the 1970s, but what about growing up? Were you always fascinated by science and human origins?
Well, like many children today, I was fascinated by fossils, by prehistoric life, dinosaurs, of course, but also humans. And so, my parents, when I was 5 or so, took me to the Natural History Museum, and I remember seeing the displays about human evolution and being very interested. And there was one about Piltdown Man, which said that the cases were under rearrangement, and that was, of course, when the forgery had just been revealed. So yeah, I can remember visiting the museum way back and being interested in human evolution. And I collected fossils. When I went to beaches where there were fossils, I would try and find some. And I did a project on Neanderthals when I was, aged about 9 at junior school. And that was inspired by some BBC radio broadcasts that I'd heard, one of which was about the Neanderthals. So I wrote this project on Neanderthals and drew pictures of skulls and evolutionary trees. It would all be pretty hopeless now, of course, if I could see it. Sadly, that project got lost. But I maintained that interest in human evolution. But I never realized when it came to career talk, no one at school ever told me that you could actually get a career in this area. So I'd never heard of anthropology as a subject at university. That's how limited, I was from an East End background with, limited career choices. So I was advised if I was bright and got the right A-levels that going to medical school or something like that would be the thing. And so, yeah, I was gearing up to train to be a doctor. I had a place at medical school. And then at the last minute, I found out about a subject called anthropology. So to the puzzlement of my teachers and the concerns of my parents, I actually fixed up an interview at University College in London for an anthropology degree instead of a medical degree. And they offered me a place, and to my parents' credit, they said, well, if that's really what you want to do, okay, we'll back you to do that. So I went to UCL, did anthropology. When I finished there in 1969, it was a bad year to try and move on to anything further. Things like PhDs were very difficult to fund at that time. But I was actually offered a temporary post at the Natural History Museum even in 1969. So that was great preparation for me. I was a temporary, curator at the museum for nearly a year. And that really familiarised myself with the fossils, and, it helped me to plan for a PhD in more detail. And then luckily a year later, I was offered a PhD place at Bristol University in the anatomy department to work with a guy called Jonathan Musgrave, and he had done a PhD on Neanderthal hand bones, going around Europe looking at the hand bones of Neanderthals. And he took me on as a PhD student. And so with his help, I was able to organise a trip to visit the European museums to look at their fossils, but this time looking at the skulls. So I was going to compare the cranial shape of Neanderthals and that of Homo sapiens, particularly the fossil Homo sapiens in Europe, to see whether Neanderthals were our ancestors in terms of their cranial shape. Did they make good ancestors for our species, which was the leading idea at the time. And my data at the end of the PhD in 1973-74 suggested the Neanderthals did not make good ancestors for Homo sapiens. So I couldn't say where our ancestors were, but I was pretty sure we didn't evolve from the European Neanderthals. So I took that work to the museum in 1973. At the end of 1973, I was offered a position there to go back. I've been there ever since. So continuing that work and expanding it, of course, not just in Europe, but to look more globally about the evolution of Homo sapiens.
Well, it was only recently, in 2021, that an apparently new human species was described and announced to the world, Homo longi, or dragon man, found in northeast China. Chris, what is the story behind dragon man?
Yes, I mean, the origins of the fossil are murky. It's a beautifully preserved fossil cranium, almost complete, although it's lost almost all its teeth. They fell out long ago, but it's beautifully preserved, the best preserved ancient fossil human from East Asia. And I was fortunate enough to be invited to work with Chinese colleagues on publishing the first description and analyses of this lovely cranium. So as far as we know, the story goes that the cranium was actually discovered in 1933 when Japanese occupiers were occupying this part of northeastern China, and they requisitioned, coerced a group of labourers, Chinese labourers, to work on building a new bridge across the river there at Harbin in northeastern China. And apparently during that work, the workmen found this beautifully preserved cranium. They didn't want it to fall into the hands of the Japanese. So one of the workmen took it home, wrapped it up and put it down a well, which is traditionally a place that Chinese people stored their treasures, down a disused well. So allegedly it stayed there for some 80 years. And then the man, near the end of his life, finally told his family to look down the well where they recovered the fossil. He died, so not around to talk about the discovery at the time it went public. And why he didn't report it earlier, well, apparently there was obviously a sense of shame in having worked for the Japanese occupiers. So this was a reason to keep quiet about it. Now, this is, the story that's come down to us, but obviously, we'd like to know much more about the circumstances. Where did it originally come from? And so we're also conducting work in the region to try and pin down more about the history of this fossil. So I think there's still more to come out about this story. But that's what we've got at the moment. And so we did conduct isotope studies on the fossil to compare it with fossils from the region and from other parts of China. And those studies at least supported the view that it came from the Harbin region. And we dated the fossil itself by uranium series dating to at least 146,000 years old. So that's its minimum age. It could be some way older than that, but it's at least that age. So that's the basic story. And it came into the hands of Professor Ji Qiang. And he obviously, he's an expert on things like dinosaurs. So he recruited other colleagues, eventually including me, to describe the fossil. And it was published in 3 papers. We did a paper describing the fossil cranium and comparing it with others. And that included a phylogenetic analysis to try and place it in evolutionary terms. And then there was a second paper about the isotope studies and the dating of the fossil. And then there was a third paper by a smaller group of Chinese colleagues, which is the one that named it Homo longi, dragon man, named after the Dragon River province. It's a great name, Homo longi, but actually my name wasn't on that paper. I prefer to name this fossil Homo daliensis because there's another fossil from China, from Dali, probably a bit older than the dragon man fossil, but our analysis showed that they were part of the same clade, part of the same evolutionary group. And there is a name for Dali already, Homo daliensis, not much used, but that name is there. So in my view, it's better to assign the dragoman skull into that Homo daliensis group rather than create another species name. But I'm very happy to use dragoman as a common name for it, but I prefer to give it the species name Homo daliensis, which for me represents this group of Chinese fossils, which are kind of like the counterparts of Homo sapiens and Homo neanderthalensis. And in China, we've got Homo daliensis.
And we're talking 146,000 years old was the dating?
That's the minimum age, yes. So it's at least that age. It could be older. And obviously part of our work will be to try and get even better dating on the fossil as time goes on. So this was only preliminary work, and there's a lot more to do on this fossil.
Chris, we can't really talk about this new species unless we examine its relationship to other hominid species that coexisted with it. In Asia, we had Neanderthals, Denisovans, and Homo sapiens existing at the same time as dragoman. So how does the presence of these other species impact our understanding of Homo longi?
Well, that's a very good question, and obviously it's something we're still working on. What our phylogenetic analyses showed that if we use all the data we have on the fossils, and so we had up to 600 bits of data available for the fossils that we were looking at, and putting those into a phylogenetic analysis to build the most parsimonious trees, the ones with the least evolutionary steps, the least evolutionary changes, gave us essentially three later Pleistocene groups. One of them was Homo sapiens, and that included obviously recent humans, recent fossils, and fossils in Africa that go back to about 300,000 years. So there was a Homo sapiens clade group, and then there was a Neanderthal clade, and that contained the familiar Neanderthal fossils that we've got from places like France and Germany, and it included some earlier Neanderthals, and it also included the material from Atapuerca, from the Cima de los Huesos in Spain, that's over 400,000 years old. So those were all in a Neanderthal clade. And then there was a third clade, which contained a number of Chinese fossils. It included the Harbin cranium, it included Dali, it included the Jinu Shan specimen, and it even included a jawbone from the Tibetan plateau of China, from Jiahe, which has been thought to be a Denisovan. So we had this Chinese clade alongside the Homo sapiens one and the Neanderthal one. And what was interesting is, if we trace those phylogenies back to their roots, and this is in the publication, so you can find these phylogenies there, our most parsimonious grouping actually had the Harbin clade grouping with the Homo sapiens clade before they both joined the Neanderthal clade. So in other words, on our analysis, the Harbin clade was the sister species of Homo sapiens, and then the Neanderthals were a further out group. Now beyond that, there were the things which I've called Homo heidelbergensis or Homo rhodesiensis, things like the cranium from Kabwe in Zambia, Petrolona from Greece, Bodo from Ethiopia. Those were a further out group to the three clades I've mentioned. And then beyond them were the Homo erectus fossils, things from Africa, from Java, and from China. So this was an interesting thing, that actually the Harbin clade seemed to be slightly more closely related to Homo sapiens than it was to the Neanderthals.
And Chris, what are the main features that differentiate each of those groups?
Well, in the cranium, which of course is the focus of our study, Homo sapiens, as is well known, we've got a high and rounded brain case. We've got small brow ridges or non-existent brow ridges at the front. We've got a face with a relatively small nose, a face that's transversely flat and that's tucked under the brain case, it's retracted under the brain case, not projecting. On the lower jaw, we've got a chin. Unfortunately, we don't have that preserved for dragon man. And there are distinctive features even in things like the ear bones, but we don't have that data for dragon man. So for Homo sapiens, there's really quite a distinctive skull shape, very recognizable in Homo sapiens and to an extent in some of those African fossils I mentioned. And then we've got the Neanderthal clade, and again, our analyses picked up on the usual Neanderthal features. So there the cranium is longer and lower, more primitive in that sense, with still this big brow ridge at the front. The face, though, is very distinctive. It's the middle of it is pulled forwards. There's a very large nose and a wide nose. The cheekbones are swept back. The front teeth are really quite large, relatively big teeth at the incisors. Not much of a chin at all on the lower jaw. And when you look at the shape of the cranium, I didn't mention for Homo sapiens that our crania is kind of wider up here. It's expanded in the upper parietal region. But for the Neanderthals, the cranial shape is almost spherical. It almost looks like a football when viewed from behind.
Rugby ball.
Yeah, well, rugby ball in the side view.
The side view.
Soccer ball in the rear view. So now, by comparison, the Chinese group, which included Harbin, had a kind of distinctive combination of features. So the long, low cranial vault was there that we find in Neanderthals, very strong brow ridge, actually bigger than typically we find in Neanderthal fossils. But the face was much more like a Homo sapiens face. It was transversely flat with quite delicate cheekbones, a very wide nose, have to be said, very big orbits, distinctive there. But the face was also tucked under the cranial vault in a way that we find in Homo sapiens. So it's an unusual combination of features. And I should mention that there's only one tooth preserved in the Harbin specimen, an upper molar, but it's huge with splayed roots, and that's distinct from both Homo sapiens and from the Neanderthals. And when we look at the outgroups, if you can call them that, things like what I'd call Homo rhodesiensis fossils, they're more primitive in some ways. They generally have big brow ridges. They have a long, low skull, but less expanded, generally a smaller brain size than we find in the groups I've already mentioned. The back of the skull is flexed. The occipital bone is flexed in side view, and it's got a ridge of bone across it called the occipital torus. So that's a more primitive feature in rhodesiensis fossils that we also find in Homo erectus fossils. And the erectus group are even more primitive. And I should say, for the rhodesiensis fossil, the face is pulled out more, and it's bigger relatively. So a more primitive morphology generally in rhodesiensis. For erectus, and even more primitive morphology. Usually a smaller brain size, really relatively big brow ridges, very poorly expanded brain case, very wide at the base, and a face that's more projecting overall compared with the other species. So that's a summary of some of the features of these groups.
So I suppose, Chris, when you first saw the Dragon Man partial skull, right away, I suppose you could see, that reminds me of that older group, and this reminds me of this later group, and you could sort of you could get a picture that way.
Yes, I mean, it was a strange combination of features, and I've actually got on YouTube a video giving my first reactions to the fossil the day that I saw this beautiful replica of it that was brought to me by my Chinese colleagues. And I remember thinking, in a way, it was a little bit reminiscent of a very primitive Homo sapiens fossil, such as Jebel Ihud from Africa, the one that's about 300,000 years old. And I remember thinking, it reminds me a bit of like Jebel Ihud on steroids, if you can imagine, that African fossil pumped up with a great big brow ridge and more primitive look. It almost reminded me of that. So it was this strange combination of features that already I could see, where you had a rather modern looking face and a retracted face, but this long, low brain case with this great big brow ridge. So a striking, quite distinctive look to it. And it's huge. I didn't mention the size of the fossil. It's the biggest human fossil I've ever seen. It's an enormous cranium, bigger than typically any of the other Homo sapiens, Neanderthal, rhodesiensis ones. Some of those are big, but this Dragon Man fossil is huge. It's an enormous. This guy, and we assume it's a man, we can't sex it reliably, but this was a huge person. The rest of his body must have been built on a similar scale.
And Chris, what about the environment that Homo longi lived in? I mean, what would he have had to cope with?
Yeah, so because we don't know the exact site that he came from and the associated animals, we don't know if he lived in a relatively warm or cold period. But what we can say is that Harbin today, even today, has extremely cold winters. It's got one of the coldest places in China in the winter. They even have an ice festival there where they build ice sculptures and leave them there for a month. And so the average winter temperature in summer months today is minus 15 centigrade. That's the average in some of the winter temperatures. So it could have been even colder in the past. If Dragoman lived during a cold stage, it could have been even colder. But even on today's winters, these people were living in extreme cold in the winter, colder than we know of, definitely for the Neanderthals. So I suspect that this large head size of Harbin goes with probably a very big body, a very short, wide body, probably adapting these people to the cold conditions, because you minimize your loss of cold by having a short, bulky, sort of round body. So that's probably the body shape that these people had. And who knows, they may have had insulated layers of fat. They may have had more body hair. They may well have had cultural adaptations, wearing clothing, having the use of fire, and so on. So there's a lot to learn about these people to come, but they certainly were coping at times with extremely cold conditions.
It must be frustrating for paleoanthropologists like yourself, Chris, not to have a time machine.
Yes.
Just want to have a look sometimes.
Absolutely. There are some critical times that I'd love to go back to see what was really happening compared with how we reconstruct it. Yeah.
Well, until quite recently, paleoanthropology relied mostly on the fossil record to make its determinations. But today, we live in the world of DNA extraction and DNA testing. Although extremely useful in understanding ancient species, it has its limitations. But new techniques are coming to light almost every year. And this includes something called proteomics. Isn't that right?
Yes. So DNA has been wonderful, and it's given us so much extra information about human evolution. And that's something that I'm involved in work on with my colleagues at the museum. And you talk to my colleague, Selina Brace, who works on ancient DNA. And so that's tremendous, and it has a lot to offer us. But one of the problems with DNA work is that the further you go back in time, the DNA is much less well preserved, and particularly in warmer conditions, it's generally preserved very badly. So we have got some ancient human DNA from the Cima de los Huesos at over 400,000 years old. It's not anywhere near a complete genome. It's bits of DNA, and we're lucky to have that. That was found deep in a cave system and preserved for that reason. But mostly we don't have DNA from fossils. There's been an attempt to get DNA from the Harbin fossil, and it's not been successful as far as I know. I mentioned a jawbone from the Tibetan plateau of China, from Jiahe, and that jawbone was tested for DNA, and it didn't have any. It was at least 150,000 years old. But what they did find with that fossil from Jiahe was that there were tiny bits of protein preserved. So proteins, of course, are the products of our DNA. They're the things that work in our body, things like enzymes, things like hemoglobin, insulin. These kinds of things obviously have their own genetic code, and we can look at their amino acid composition if they're preserved. And so what scientists are doing now is looking for proteins in fossils, and we know these preserve much better, in some cases for many millions of years. So although they're less informative, if we can get enough evidence, we can still build up a database to compare, let's say, the Harbin group with Homo sapiens, with the Neanderthals, potentially with Homo rhodesiensis, potentially with Homo erectus, and even earlier human-like forms. So the hope is that proteomics in the next few years will develop into a field that gives us a much deeper reach in time, although with less information in each case than we have for the genomes, but still informative about relationships. And the interesting thing is that the bit of protein that was found in the Jiahe jawbone linked it with the Denisovans rather than with the Neanderthals or Homo sapiens. So that jawbone provisionally is identified as a Denisovan, but it was only a tiny bit of genetic information in the form of some bits of protein. So the way forward is to get more and more data, and gradually we can build up a network comparing these fossils beyond the reach of DNA. So it's got great promise, and I'm involved in a project to work on our fossils at the museum, and hopefully some of those will have protein information, and we'll be able to start building a database to compare them, and hopefully the dragonman fossil will have preserved proteins, and that may help us place it in relation to other human forms.
And this all relates to your upcoming collaboration with the Crick Institute?
That's right. Yes, I have a project with a couple of colleagues at the Crick Institute, and we hope very much that obviously it's going to yield fruit in terms of data from some of our museum fossils, but we're just starting that project now. But watch this space. Maybe invite me back in a couple of years' time, and I can tell you if we've had any results.
Well, maybe even going back to as far as Lucy's time, 3 million years and beyond, that would be amazing.
Well, potentially, yes. There is protein material now from a rhinoceros fossil that's nearly 2 million years old. So there is the potential there that it will be there in more ancient fossils, because the good thing is there are obviously a huge number of proteins in our bodies. So, they each have their own probably, preservation potential, but between all these proteins, we should find ones even in fossils that are millions of years old.
When people think of all the fascinating hominid species that once existed and coexisted on our planet, we can't help but wonder why our own species is the only one left. So I guess a question that a lot of people ask you, Chris, is where did all of those other species go?
Yes, that is a question I ask very often, and it's a very difficult one to answer. We don't really have an answer for it. We can observe the fact that there were at least 5 kinds of humans around on the Earth, even 70,000 years ago, which is like yesterday, geologically speaking. So we had been evolving in Africa. The Neanderthals had been evolving in Europe and Asia. The Denisovans were over in the Far East and Southeast Asia. In Southeast Asia, we had these strange dwarf species, Homo floresiensis on the island of Flores and Homo luzonensis on Luzon in the Philippines. But Homo sapiens emerged from Africa in a main dispersal about 60,000 years ago on genetic estimates. And that move out of Africa, as well as staying behind, began the diversity of Homo sapiens as we know it today outside of Africa. And within 20,000 years of that, it seems that those other species had gone physically extinct. Now, we know they hadn't gone completely extinct in the case of the Neanderthals and Denisovans, because there was interbreeding before they went extinct. So people today have DNA from Neanderthals and DNA from Denisovans in their genomes. But those species physically disappeared. And why did they disappear? Why are we the only survivors of all these experiments, if you like, in how to be human? It's a big question, and some of the leading ideas are that, well, obviously one idea is that we kind of killed them off, and I don't think there's any evidence for that. And it certainly wasn't an instant disappearance. We overlapped with the Neanderthals in Asia, certainly in Western Asia, potentially for 20,000 years before they disappeared. Some people have suggested we might have brought diseases from Africa that they had no resistance to. But equally, you could say that we wouldn't have had resistance to the diseases that were in Asia and Europe when we went into those areas. And actually, it seems quite likely that our interbreeding with the Neanderthals and Denisovans actually gave us advantages, because we gained some of the immune system protection that the Neanderthals and Denisovans had evolved, and that helped us in moving out of Africa. So the idea that an epidemic killed the Neanderthals off seems very unlikely, and these populations, of course, were living at very low density compared with the greater densities of populations that we think of in the last few thousand years that are much more densely packed, where epidemics can spread very rapidly. So I don't think that's likely to be an explanation. Environmental change certainly could have contributed, because we know the climates were very unstable. As Homo sapiens spread out between 40 and 60,000 years ago, the climate of the Earth was extremely unstable, fluctuating from relatively warm to extremely cold over and over again. And that would have meant a destabilizing of the environment, but that would have affected Homo sapiens as well. So why was it that these other species died out? Competition from Homo sapiens, I think that seems to be a factor. There was probably economic competition because Homo sapiens, of course, would have had the same lifestyle as the Neanderthals and Denisovans in terms of wanting to hunt the same animals, collect the same plant resources, wanting to live in the best places. So there could have been an economic competition where Homo sapiens had even a slight advantage, which over thousands of years could have made a difference. And that advantage could be an advantage in some way. Some people think cognitive, advantage, complex language, a more complex system of communication, greater networking across the landscape between Homo sapiens groups. Because what we do know is Neanderthals were, at the end of their time, towards the end of their time, they were relatively low in numbers and relatively low in diversity. So in a sense, they could already have been a threatened species, and then another human species comes to live alongside them and competes with them. And I think actually the absorption of the Neanderthals was probably a factor in their demise as well. That we know that individuals were joining the Homo sapiens groups. We know that because there's multiple evidence of interbreeding between Neanderthals and Homo sapiens within the Homo sapiens groups. So that means Neanderthal partners were joining those Homo sapiens groups voluntarily or involuntarily. We don't know the circumstances, but that meant the Neanderthals were therefore losing their own prime age breeding individuals to another species. So that could have been a contribution. So yeah, there are many explanations around. We don't know the full story, but I think it's likely to be a combination of features rather than a single thing. But I think that economic competition was certainly a major factor. And what's, of course, got to be considered is not just the disappearance of Neanderthals. We've got to also explain the disappearance of Denisovans. And that's, in a sense, even more difficult. First of all, we got much less data about that, but also the Denisovans were widespread, probably across Eastern Asia and Southeast Asia. So they were certainly up in Siberia. And we think because the DNA of Denisovans is particularly prevalent today in people in the Philippines, in New Guinea, Australia, and so on, it's likely that the Denisovans were on the islands of Southeast Asia. And when Homo sapiens came through there was interbreeding. So the Denisovans were living in very cold conditions up in places like Siberia. Possibly, some people think Dragon Man could be a Denisovan, and that's something we didn't talk about, but it may well eventually turn out to be true. Because, of course, we've got this strange situation on DNA evidence. We've got sapiens, Neanderthals, and Denisovans in East Asia. On morphology, as I mentioned, our analyses showed sapiens, Neanderthals, and the Harbin clade. So why don't we just say the Harbin clade must be Denisovans? Well, we don't have strong evidence for that at the moment. It's certainly a possibility. So the Denisovans were living in cold conditions in the north and tropical and subtropical conditions at the south of their range. They were genetically more varied than Neanderthals on the existing data we have, and yet they also disappeared in this 20 or 30,000 year period when Homo sapiens came into the region and eventually replaced them. But they, as I stressed, they did not go completely extinct because a lot of their genomes live on in us today, both Neanderthal and Denisovan.
That's right. I think Europeans have 3 to 4%, but and if you look at people from the Philippines, you will find more Denisovan DNA. Is that correct?
Yes, so I think it's about 2% in most people outside of Africa, 2% Neanderthal in their genomes. But over in the Philippines and some parts of Australasia, there's an additional component of sometimes around 4% of Denisovan DNA. So in a sense, they've got that double dose of introgression, both Neanderthal and Denisovan. So in total, about 6% of their genome would be coming from these other human forms.
Chris, you've just released a new edition of your book, Our Human Story. You've been working on Dragon Man as well as the proteomic research. Now, are there any other projects that you're working on or that are coming up that you can tell us about?
Well, yes. So we mentioned DNA work, and I'm carrying on working with Selena and Ian at the museum and other colleagues in working on DNA of ancient humans. I'm sure Selina, she must have talked about Cheddar Man and the material from Gough Cave in Somerset. So as well as getting a whole genome of an individual who lived about 10,000 years ago, we're also trying to get DNA from humans who were around about 15,000 years ago, associated with a British version of the Magdalenian culture that we know of from the late Paleolithic of Europe. And these people were living in Gough's Cave in Cheddar Gorge. Some of them are cannibalized, so they're famous or infamous for that reason. But we're starting to get DNA from some of these individuals, and we even hope to have evidence of the relationships of these individuals. So if we can get detailed enough data, which is being done for other sites now, you can start to actually build up kinship relations of these individuals. Have you got siblings there? Have you got parents and children? So this kind of work is happening in other sites, and we hope to get it working on some of these British fossils. I've also got a project on cave sediment DNA going on, and this is another thing we didn't get a chance to talk about. But what's interesting is that, of course, most of the work we've talked about so far is DNA from the fossils themselves. But the incredible thing is that in the sediments of caves and potentially even of open sites, there could be DNA from humans that lived there previously, even if you don't have their bones. So in a cave, if an individual relieved themselves in the cave, if a woman gave birth in the cave, if an individual, a bit of him was dragged in by a hyena, or her were dragged in by a hyena, and everything else dissolves away, there could still be traces of DNA in the cave sediment. So this is being worked on increasingly, and there are some sites where there's actually more evidence of early humans from the cave sediment DNA than there is from the fossils. So potentially we can find DNA of a Neanderthal even where there isn't a single Neanderthal fossil in the site. Even if there's one stone tool showing us the Neanderthals were there, that Neanderthal may have left their DNA in the cave. So that's a project that's being worked on at Denisova Cave itself, where they've got large numbers of sequences of animals that were living there and of the early humans, Neanderthals, Denisovans and Homo sapiens, just from cave sediment. We're applying that to some sites in Britain now to see if we can recover sediment DNA, even of the Neanderthals that we know were living in Britain, even though we have a very sparse fossil record. And I'm also looking at dating work on fossils. So this is something, a long-term interest, particularly with a colleague called Rainer Grün. We dated the famous Cabway or Broken Hill fossil to around 300,000 years ago, a couple of years ago. There are still some other fossils that we hope to get better chronology for.
Well, your decades of work at the London Natural History Museum have been very important indeed, advancing our knowledge on the human story, and I'm very grateful that you were able to take time out of your schedule to talk to us today. I will leave links to your books, research papers, and social media in the description below, and hopefully we can have you back on the show in the very near future.
Well, great. I've enjoyed being with you, and yeah, it will be my pleasure to come back and update you on some of this work. And who knows, it's always difficult to predict what's coming, and so many surprising discoveries. I'm sure there'll be some more by the time you ask me back again.